Greetings to all. I am Twinkle Mishra of Inspiration College of Teacher Education, subject Pedagogy of Mathematics, presenting my PPT on Pythagoras, the great mathematician. Pythagoras said number is the ruler of forms and ideas and the cause of gods and demons. Pythagoras was a Greek philosopher and great mathematician from 1570 to 495 before Christ. He made influential contribution to philosophy and religion in the late 6th century BC. He had great impact on mathematics, theory of music and astronomy. He is often referred as a great mathematician and scientist and is best known for the Pythagoras theorem that was proposed by him. Now, talking about the early life. Pythagoras spent most of his early childhood at Samos. At first, he studied from the scholars of Syria. His mating with Thales elicited in him an interest in science, mathematics, and astronomy. He then went to Babylon and began to study the subject of his interest called mathematics. The later life of Pythagoras. The Pythagoreans, as followers of Pythagoras, were called. They lived and worked at the school. Like most genius people are, Pythagoras also had many enemies. One of them instigated mob against Pythagoras and set fire to the building where they were staying. However, Pythagoras was able to escape. He then went to Metapontum and starved himself to death. Pythagoras believed, he staunchly supported that everything could be reduced to numbers and these numbers had their own characteristics. To him, 10 was the most complete number because it was made up of the first 4 digits and when written in dot notation, they formed a triangle. He also believed geometry to be the highest form of mathematical studies through which one can explain the physical world. Pythagoras and his contribution to mathematics. Pythagoras made many contributions to the world of mathematics, including studies with even and odd numbers, studies involving perfect and prime numbers, irrational numbers, various theorems, ideas about triangles, parallel lines and circles, and last but not the least, the most important, the Pythagorean theorem. Works of Pythagoras. Pythagorean theorem, it states that the square of hypotenuse, the side which is opposite to the right angle, is equal to the sum of squares of the other two sides. That is, a square plus b square is equal to c square, where a and b are adjacent sides opposite to the hypotenuse which is depicted as c. Proof of Pythagorean theorem. The two large squares shown in the figure here depicted in the pictorial representation, they contain 4 identical triangles and the only difference between the two large squares is that the triangles, as we can see, are arranged differently. Therefore, the white space within each of the two large squares must have an equal area. That equates the area of the white space which yielded the Pythagorean theorem. Proof of the theorem. This can be easily understood by this pictorial representation. Uses of the theorem. The Pythagorean theorem occurs in the following. In engineering calculations, it finds wide application. In oceanography, so as to determine the speed of sound in water. It is also used in aerospace industry. It finds wide application in meteorology and geology. The triplet. Pythagorean triplet consists of three positive integers a, b and c such that a square plus b square is equal to c square. Such a triple is commonly written as ABC. Pythagorean triplet is one in which a, b and c are co-prime. Some examples are given like 3, 4, 5, 5, 12, 13, 20, 21, 9, 29 respectively. The tetrasides is a triangular figure consisting of 10 points arranged in 4 rows, which is the geometrical representation of the fourth triangular number, as depicted in the pictorial representation. An example of Pythagoras tetrasides having 10 dot structure is depicted here. Uses of the tetrasides. The tetrasides generally occur in the following: the baryon decuplet, in the archbishop's coat of arms, the arrangement of pins in 10-pin bowling, a Chinese checkerboard, the Christmas tree formation in association football. The famous quote by Pythagoras, "There is geometry in the humming of the strings. There is music in the spacing of the spheres." Such great was the mathematician called Pythagoras. Thank you for being a patient listener. Thank you, one and all.